Hello, we are back with Chapter 6 on Similarity, where we are focusing on sections 6.4 and 6.5, Day 1. The learning target today is I will be able to determine if two triangles are similar using angle-angle, side-side-side, or side-angle-side shortcuts. So here we go. We are going to be looking at three shortcuts. The first one is angle-angle. So I would like you to, while you are going through this Edpuzzle video, to please take notes on these. We will be using these in class to solve problems. So it would be helpful to have these in your notes. So draw the diagram, write the words that we will have here, label them angle, angle. So you're going to label all three of the shortcuts, and then we will have a few practice problems at the very end. So we have angle, angle, if angle A is congruent to angle D, and if angle C is congruent to angle F. So we have two pairs of corresponding angles that are congruent to each other. They're equal in measure. Then by the angle-angle similarity shortcut, we can say that triangle ABC is congruent to triangle DEF. Notice when I write my similarity statement that my angles that are congruent to each other are in the same relative position. If angle A and angle D are congruent, they're both listed. Here in this case, they're both listed first. Angle C and angle F are congruent. They're both listed in the same relative position. In this case, they're both listed last. We don't need to show that it's angle, angle, angle. However, if you have two angles that are congruent to each other, two corresponding pairs of angles, those third angles are going to be congruent also. So angle B and angle E are also congruent. Because all three of the angles in one triangle will add up to 180 degrees, and all of the angles in the other triangle add up to 180. So if angle A and angle D are congruent, angle C and angle F are congruent, angle E and angle B will have to be the same measure. If you need more time on any of these slides, please pause the video and make sure that you get all of these in your notes before you continue. I'm going to keep going. So the next shortcut is the side-side-side shortcut. Again, make sure that you are taking time to write this down. So pausing when you need to. For the side-side-side shortcut, for similar triangles, we would need the three pairs of corresponding sides to be proportional. So AB is to DE. That ratio needs to equal the ratio of BC to EF. These are corresponding sides. Has to also equal the third set of corresponding sides. Those ratios all need to be equal to each other, and you need to show it. So let's go through that work and actually show that those are equal ratios. So in these triangles, I have triangle ABC, and it's been enlarged. The corresponding side is DE. So those two sides are corresponding. The length of AB is 3. The length of DE is 6. If we simplify that ratio, how can we simplify 3/6? What would that equal? I could divide top and bottom by 3, and it will equal 1/2. My second set of corresponding sides, my blue ones, are also 3, and 6. So BC is length of 3, and EF is a length of 6. And we can see that that is also going to be 1/2. And then my third set of corresponding sides, AC and DF. Notice again, we talked about this in class, that I am using these with dots instead of tick marks because tick marks mean the sides are equal in length. These are not equal, but I want to still show which ones correspond to each other. So the length of AC is 4, the length of DF is 8, and if we reduce that ratio, I can divide top and bottom by 4. That ratio is also 1/2. So in order for us to use the side similarity shortcut, all 3 pair of corresponding sides have to be proportional, which means their ratios are equal. All 3 of these fractions are the same. If they're all the same, then by the side similarity shortcut, my triangles are congruent. Sorry, my triangles are similar. Triangle ABC is similar to triangle DEF because all 3 corresponding sides are proportional. And then finally, my third shortcut, my third similarity shortcut is side angle side, where you can give a little sass. We need 2 sides and the included angle. Remember, the included angle is the one that's right between those 2 sides. So let's look at this. We have side, angle side. That angle is in between. It's formed by the blue side and the green side. The blue side and the green side. So this angle and this angle are in between. So that's what included angle is. So if we're going to use side angle side, if we know that the ratio of AB to DE is equal to the ratio of BC to EF. Again, anytime we are using sides, we need to show that those ratios are the same. So let's actually work through that because we do need to show the work. So we're saying that AB and DE are corresponding sides. So let's show their ratio. There's the ratio. If we're going to reduce the ratio so that we can compare it to the ratio of BC to EF, how can we simplify this? What would we divide top and bottom by? We can divide top and bottom by 5 and tell me what my reduced ratio then would be. Three halves. And then let's look at BC is 9, and that corresponds to side EF, which is 6. Well, can we divide top and bottom by here to reduce it? Divide it by 3. And so this reduces also to 3 halves. So here we have both pairs of corresponding sides are proportional, meaning that those 2 ratios are equal to each other. The ratio of AB to DE, which is 3 halves in this problem, and the ratio of BC to EF, which is 3 halves in this problem, they are equal to each other. So I have my 2 sides, and then I also need my included angle, corresponding angles, to be equal or congruent to each other. Angle B is congruent to angle E. They have the same measure. Then by the side angle side similarity shortcut, those two triangles are similar. Triangle ABC is similar to triangle DEF. So those are the three shortcuts that we have. Angle, angle, side, 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 angle, side. For all three similarity theorems, the corresponding angles are congruent. They're equal in measure. The corresponding sides are proportional, the same ratio. You do need to show anytime that you're dealing with something that has sides. So if you're doing side, 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 or side, angle, side, you need to be able to show that those sides have the same ratio. So you'd actually need to write it down and show that. So let's do a few problems here. In these examples, for each one of these, you will need to write the similarity theorem, which one we are using to prove that the triangles are similar, and then you need to write a similarity statement. Triangle what is similar to triangle what? And remember, you need to get those triangles listed in the correct order. So let's do these. All right. So let's look at the first problem. Looking at that, how many pieces of information do they give us outright? How many are listed like as givens? I see two pairs of sides. On triangle ABC, they give me a 3 and a 2. On triangle DEC, they give me a 6 and a 4. I only have 2 pairs of sides. Which similarity theorem do you think we can use on this one? I notice that I have vertical angles. So I have two sides, and I want to know which side corresponds to the 3 and which side corresponds to the 2. So on my larger triangle, which side is going to correspond to my 3? That will be the 6. Actually, let me write, I'm going to write AC is to DC, 3 to 6. We need to reduce that. And then let's also look at BC and EC. Two to 4. And if we are going to reduce these, what is going to be the ratio? This one will be 1/2, and this one will be 1/2. So we have both of these are in the same ratio, so those are proportional. And we have our two angles. So what is going to be my theorem? That will be side angle side. And then we need to write the similarity statement. If we start with angle A and we go to C, let's see if we can figure this out. If we start at A and we go toward C, where are we going to start with our other triangle? We would need to start with D, and we're going to go along that side that is corresponding. So that would be DCE. What theorem do you think we can use on example number 2? Look at what they give you. What do they give you? How many pieces of information? I notice that I have some angles, and they already have them marked. Angle C and angle D are marked with 1 arc mark. Angle A and angle E are already marked as congruent with 2 arc marks. So we have, actually let me list these out. I have angle, and I should probably write that over here also, that angle ACB is congruent to angle DCE, because I need to show that my 2 sides are proportional and my angles are equal. And then let's write these. I have angle C is congruent to angle D. Those are listed with 1 arc mark. And angle A is congruent to angle E. This will help us write our similarity statement also. So what's the theorem? That would be angle, angle. And then if we are going to start with A to B to C, if I'm going to start from A to B, what is my corresponding angle for A? How am I going to write the other triangle? Yes, I need to start with angle E, and if I go from A to B, B is the unmarked one, I'm going to go toward F. So that would be triangle EFD. Very good. Last example. What do I notice here? I've got lots of sides marked. I've got all of the sides marked. So I know that I can use side, side, side as long as my sides are all proportional. So I do need to show that. So let's do this quickly. If I have AB, now here, this could be tricky if things are twisted or rotated or flipped. But notice I have, here's what I'm going to do. I'm going to list these out, see if I can have enough room. I'm going to list these out in order. So 3 is my smallest side, my shortest side. 4 is my next shortest side. And 6 is my longest side. They need to correspond to each other so that my shortest side here needs to correspond to my shortest side here, which is 12. So then my 4 is going to correspond to what? The middle sized, which is, whoops, which is going to be 16. I put too many marks on this one, sorry about that. It should only have 1 mark, whoops. There we go. And then my longest side on my small triangle should line up with the longest side. And that will help you if they happen to be rotated or flipped. And then let's reduce these. Can you figure out what the reduced ratio will be for all of these? I can divide those by 3. I can divide top and bottom by 4. I can divide top and bottom by 6. So I have all of my corresponding sides are proportional because they have the same ratio. They're all 1/4. So I can do side, 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 similarity. And then finally, how can I write my similarity statement? So let's quickly look at this. If my first one is A to C, I'm going along the red one. So I would want to go from D to E, because these are just, they haven't been rotated. So it's just been enlarged and slid down. So that would be D, E, F. Very good. All right, so those are all of the examples. Make sure that you watch this video all the way till the end so that you will get all of the points for this Ed Puzzle video. And then we will see you tomorrow in class, or Thursday or Friday in class. Please bring your notes to class so that we can use those when we are solving some problems. Thank you very much. Have a great day.